Hello, Algebra 1B students. If you're looking at the mid-chapter review, I want to read through this and maybe give you some verbal ideas on how to attack these problems. And you could pause this video as needed if you're writing down some of your answers. I'll give you as much information as I can to clarify this, and hopefully this helps you work out. Number one. The graph shows the number of slices of French toast in a serving dish at a breakfast buffet as time passes. What are the variables? Describe how the variables are related at various points on the graph. All you're going to do is label the variables, and you're going to have time being the independent variable here, and French toast being the French toast slices being the dependent variable. Over time, you could see that you're going to want to write something in your description about, over time, there's less and less French toast slices until at some point, about in the middle of the time, it's replenished, and then, French toast starts to slowly disappear once again. Slowly get eaten up, get taken out of the bin. Moving on to number 2, it says sketch a graph of the height of each object over time and label the sections. So for number 2, you throw a flying disc into the air, it hits a tree branch on its way up and comes to rest on a roof. It stays on the roof for a minute before the wind blows it back to the ground. So you're going to want, like an L graph like this. And then you could have time being your independent variable again, and then your dependent variable, the one going up, could be the height. And then you might want to show it going up, and then it stays up on a roof for a minute, and then it finally blows down, and so it comes back down on the height. For number 3, an elevator fills with people on the ground floor. Most get off at the 7th floor. The remainder get off on the 9th floor. And the two people get on then 2 people get on the 10th floor and are carried back to the ground floor without any more stops. So, you might want to have as your independent variable the floors. What floor it's going to, and then maybe the number of people be the dependent variable, and then so you start off with all these people, and then it goes down. I think it says on floor 7, most of the people get off, and then the remainder, so it's going to kind of have a flat line over to the 9th floor, and then 2 people get on the 10th floor, so it goes back up a couple on the 10th floor, and then it carries on for the rest of the floors all the way to the ground floor, without any more stops. So just make that look, however you can depict it on an L-shaped graph like that up there for number 1. Okay, for each table, identify the independent and the dependent variables, and then describe the relationship using words, an equation, and a graph. So for number 4, remember the input, the x value. Input is independent. Input, independent, x value. So these are going to be the inputs, or the x values, the variables, the independent variables. So is this. This is going to be the input. Okay. And then the output is the y, or the dependent variables. The dependent variables are here. This is one soda, and this one is the number of biscuits for dog treats. Okay. So just so you know, when you're getting to the graph on this, you're going to, this one's going to be going up, and this one's going to be decreasing. The number of biscuits is going to be decreasing when you do draw that up. And just use this information to draw it up. And then you could describe it like, starting the number of cans and soda in ounces. For each, number of cans, it's is multiplied by 12. Okay, so 2 times 12 is this, 3 times 12 is that, is multiplied by 12 ounces. An equation good for this one would be, y equals 12x. This one, Worked this one out earlier, and actually, if you start with 23 minus x times 3, you'll get the y value. So, that would be a good equation for it. It would work. Also, it would be going down. And for every trick, there are 3 less biscuits starting with 20. So that's why I started with 23. So in other words, I'm saying this, y equals negative 3x plus 23. So, if I put in a 1 here, this is negative 3 plus 23, that gives me the 20. If I put a 2 in here, it gives me 17. If I put a 3 in here, it gives me 14. If I put a 4 in there, it gives me 11. So that's what I was talking about as far as the equation goes. These are pretty simple. You got to take a look at these, the input, the output. If it helps to graph them, go ahead and graph 6, 7, and 8. But you're to tell whether the function shown by each table is linear or nonlinear. And for number 9, does each graph represent linear function or nonlinear? Remember, linear is a line. So you're going to, which one of these makes lines, you're going to put lines. There's 2 lines, there's 2 linear, there's 2 nonlinear ones. For number 10, it says the size of bees' nest increases as time passes. Your friend says that time is dependent variable because size depends on time. Is your friend correct? Explain. You might want to explain that your friend is making a terrible mistake. And the reason being because it's because size depends on time, not time depending on size. So he's got it backwards. So size is the dependent variable. And then for number 11, with some functions, the value of the dependent variable decreases as the value of the independent variable increases. What is a real-world example of this? You could use anything that maybe decreases over time or decreases, we thought of like a car driving many miles and how much gas is left in the tank. So, I get in my car and I start driving on the freeway. The more miles, the less gas I have in the tank. Okay, hopefully these help, and good luck with this mid-chapter review.